So enemy value theorem. If the function is continuous, just to review real quick, continuous on a closed interval a to b, which f of a is not equal to fb, then there is a number between f of a and fb that exists at least one number c, which f of c is equal to k. So as long as k is in between a and b. So, in other words, if a continuous function takes on all values between any two values. All right, so if f of a is equal to 1 and f of b is equal to 5, then somewhere in between there, you're guaranteed every number that exists between 1 and 5. You're not guaranteed any number outside of 1 and 5, but every number between 1 and 5 you are guaranteed. The idea we use the intermediate value theorem mainly for is to verify that x0 exists if f of a is negative and f of b is positive, or if, vice versa. So if f of a is positive and f of b is negative, then a 0 must exist in between there. No choice. It's continuous, 0 must exist. All right. Now, what you're going to need to worry more about is the mean value theorem. So, if f is continuous on the closed interval, a to b, and differentiable on the open interval from a to b, then there exists at least one number c in which the interval is a to b such that f prime of c is equal to f of b minus f of a over b minus a. That the idea is that the instantaneous rate of change. Man, I can't write. I can't do it. I don't even know that spelled correctly. Rate of change is equal to the average rate of change. That's the mean value theorem. There's at least one value in which the instantaneous rate of change is equal to the average rate of change. Has to be. No choice. There'd be more than one, but there's at least one. All right. So let f be a function that is differentiable on the open interval from 1 to 10. Now again, if it's differentiable, what do we also know it is? Continuous. So if f of 2 is equal to -5, and f of 5 is equal to 5, and f of 9 is equal to -5, which of the following must be true? Now, notice that we had an increase from 2 to 5, and then a decrease from 5 to 9. Okay? So f has at least 2 zeros. That must be true. Has to be true. Right? Because f of 2 is negative, f of 5 is positive, it has to cross the x-axis somewhere between 2 and 5. And f of 5 is positive, f of 9 is negative, it has to cross the x-axis again somewhere between 5 and 9. So, true. The graph of f has at least one horizontal tangent. Now, if I'm increasing from 2 to 5 and then decreasing from 5 to 9, what has to happen somewhere around there? It has to have a turning point somewhere. So yes, it has to have at least one horizontal tangent. All right. Specifically, because we know it's differentiable, we can't just say there's a sharp turn there. Okay, because that's possible if it didn't say it's differentiable. But because it says it's differentiable, there are no sharp turns. There are no horizontal or vertical tangent lines. There's nothing that's going to keep my function not being continuous because it's differentiable on the interval. All right, for some c between 2 and 5, f of c is equal to 3. Well, let's do this. 2 and 5. Oh, it's not f prime of c, it's just f of c. So that is the what? the IVT. All right. So since f of 2 is equal to -5 and f of 5 is equal to 5, does 3 exist somewhere in between -5 and 5? Yes, so that is also true. So all of them B. All of them. All right. If they said f of c is equal to 6, then no. All right, that's not true. But yeah, there has to be 3 somewhere between there. All right. This one was a fun one. Which of the following statements must be true? So the minimum value of f on 0 to 4 is 2. Now the function is continuous and differentiable on the closed interval from 0 to 4. The table gives us select values of f on the interval. Which of the following statements must be true? Are you guaranteed that the minimum value, the absolute minimum, is 2? No. The absolute maximum is 4. Nope, not guaranteed that. F of x is greater than 0 on the entire interval. Are you guaranteed that? No. Got some weird functions in between 0 and 1. Okay. Because the function is continuous and differentiable, and we're only given just points on it, we can't assume that the function goes directly in between those two values. Okay, we just can't make that assumption. F prime of x is less than 0 for 2 less than x less than 4. From 2 to 4. Because it could technically. Yeah, no, because it could do all kinds of things. Again, f prime of x is whether the function is increasing or decreasing, and we could just be a big wavy sign between them. I mean, it has the value, but it's definitely between those numbers. Yeah. There exists c such that between 0, c, and 4, for which f prime of c is equal to 0. That is true. That is guaranteed. E. Because this is the mean value theorem that f prime of c will equal the f of b minus f of a over b minus a, and that's 2 minus 2 over 4 minus 0, so 0 over 4, or 0. So you're guaranteed that there's f prime of c that's equal to 0, because it does follow the mean value theorem, the MVT. All right, because it is continuous and differentiable. So therefore, this is true. Just E. F is continuous on the interval and differentiable on the interval, which means the IVT applies, the MVT applies. All right, so which of the following could be false? This is the MVT. Is that going to be false if we're guaranteed this and this? So, yes, not it. All right. E. We're not guaranteed that f prime of c is equal to 0 because we don't know what a and b are. All right. We do know we have a minimum value and there's a maximum value. We are guaranteed that because that is the EVT. Remember the EVT? Extreme value theorem. If you are continuous and differentiable on the interval from A to B, then you are guaranteed to have at least a maximum and minimum value. Okay? You are absolutely guaranteed if you're continuous and differentiable between two endpoints. There must be a min or max on that endpoint. Or somewhere in there, including the endpoints. So yeah, both these apply to the EVT. Right, it says calculate. That's nice. So let our function be defined as f of x is x plus natural log of x. What is the value of c for which the instantaneous rate of change is the same as the average rate of change over 1 to 4? So we do need to find the average rate of change first. So, let's see here. What is f of 4? That is 4 plus natural log of 4. And f of 1 is 1 plus natural log of 1. What's natural log of 1? 0. So, f of 4 minus f of 1 over 4 minus 1 is 4 plus natural log of 4 minus 1 over 3, which that gives you 3 plus natural log of 4 over 3. All right, what's the derivative of x plus natural log of x? 1 plus 1 over x. So we set that equal to 1 plus natural log of 4 over 3. So x is equal to 3 over natural log of 4. You didn't even need your calculator for that, did you? See what that is. 2.164 b. There you go. Why you would need your calculator for that? Or how you would need your calculator. Questions on number 8? Let f be twice differentiable function, such that f of 2 is 5 and f5 equals 2. Explain why there must be a value for c such that 2 is less than c less than 5. C. Such that f prime c is equal to negative 1. All right. 1, f is differentiable and therefore continuous. All right. So 2, the MVT applies. F prime of c is equal to f of 5 minus f of 2 over 5 minus 2, which is 2 minus 5 over 5 minus 2, which is negative 1. You do need both of those statements. That is continuous and differentiable. Why do you know it's continuous and differentiable? Because it tells you it's differentiable, therefore it's continuous. And the MVT applies because it's continuous and differentiable. So, like h of x equal f of x minus x, explain why there must be a value r that h of r is equal to 0. Well, h of x is the difference of two differentiable functions, because x is differentiable. Therefore, h of x is continuous. So that's 1. 2, MVT applies. So, h of prime of x, h prime of whatever, h prime of r, is equal to f prime of, well, r minus 1, which is equal to, again, b, f of b minus f of a, or b minus a, which we already know to be negative 1. So f prime of r minus 1 equals negative 1, which you can add the 1 over 0. Suppose an object moves along a straight line modeled by the position function. Find the maximum velocity of an object between times t equals 0 and t equals 10. How do you find the maximum velocity? First, we need velocity, right? So v of t is equal to what? 3t squared minus 2, or 4, we'll go with 4t, plus 1. So that's your velocity function. And if I want to maximize the velocity function, what would I do with this? So v prime of t is what? 6t minus 4. Set that equal to 0. So it gives me t is equal to 2/3. So I'm going to find v of 0, v of 2/3, and v of 10. Why am I doing 0 and 10? Because I have to include, this is EVT basically, I have to include the endpoints. Because they could be the max value as well. So if I plug in 0 and plug this into the velocity function, so if I plug in 0, I get 1. Plug in 2/3, we get 3. Negative 0.3 repeating. If I plug in 10, that probably is going to be my max value here. So 300 minus, clear this, 300 minus 40 plus 1, 261. So when is my max value? Max velocity is 261, and this doesn't tell us what units. So units per t, I don't know what time t is, at t equals 10. All right. A function f is defined on the interval from -4 to 4 to certain values of the domain and range are listed below. Assume the derivative f exists at each input in the domain of f. Between what inputs must f have a critical number? So, the idea here is, where does f have critical numbers? Like, just function-wise, where does the function have critical numbers? Or how do we find critical numbers of functions? So let's ask that first. How do we find critical numbers? Take the derivative and set the derivative equal to 0. Now, what's happening on the left and right side of those derivatives? The derivative goes from positive negative or negative positive. And again, where a derivative is positive means f is increasing, or derivative negative, f is decreasing. So we need to find where the function is changing from increasing to decreasing or decreasing to increasing. So from negative 51 to negative 17, that is increasing. So just going to put increasing. Negative 17, negative 1, increasing. So no critical values between them. Negative 1 to 3, still increasing. But from 3 to 1, it is what? Decreasing. All right. So what we don't know is, so it can, because we be very careful about this. We don't know where the decreasing or increasing stops and decreasing starts. Okay? It could go from negative 1, between negative 1 and 3. So it could be between here, okay, or here. So I'm going to say that somewhere between x equals negative 2 and 0. There must be. Do I know where the decreasing or increasing starts or stops? Because what if it went from, like, what if at negative 1.5 it went up to 5? You can assume that the function's consistent between there. Okay. All right. So now that we're decreasing 1 and negative 1, we're decreasing. But negative 1 to 3, what? We're increasing. Again, I don't know if I went down to negative 2 here and then started increasing. So I'm going to go from negative 1 to 1. Wait. Was it negative 1 to 1 or what? 0 to 2. Sorry, 0 to 2. And then it's increasing. So yeah. Let me check something here. Let's see if that question's on here. Yeah, you don't have a question like that on your test. Because that's kind of too vague. I don't really. It's a good thought, but it's a little vague. This question, though, is definitely on your test.
We're explaining the last one.
What? This one?
Yeah.
Oh, okay. Again, the explanation is this: the fact that it changes from increasing to decreasing, and then changes from decreasing to increasing. We just don't know where in there it changes. Okay, but we do know somewhere between these two values, it definitely does go from increasing to decreasing, and then decreasing to increasing. Yeah, we just don't know where. So that's why we kind of fudged a little bit and said, we'll go one more over. Because I don't know if it went up to 5 here, or if it was strictly, between 1 and 3, and this is the max value between. It doesn't specifically state that that's the max value between those two numbers. It just says that is the value for f of x at that value. So I don't know if it went up to 5 and then went back down, or if it went, to 3 and then started going down after 3. I don't know where it started to decrease after that. So it could have been after -1 or before -1. It may just be me being picky and overthinking it, but I don't know. I don't like that question that much. It's not in your test. Don't stress it. The figure above represents the function f, which changes concavity at d and h. That's nice. It tells you. Okay, so right here, my inflection point. Leave the chart by indicating where the functions are positive, negative, or 0. So this is understanding your relationship between your function, the derivative, and the second derivative. So where your function is increasing, your derivative is what? Positive. Okay. Where your function is decreasing, your derivative is negative. So, all right. So at A, all right, at A, the function is increasing or decreasing? Increasing. At B, it's increasing. So at A and B, all right, since the function is increasing,
That's just silly value. You would be negative.
oh, they want positive or negative. They just want positive or negative. That's right. So in this function, A is negative, B is 0. We can just say what the functions are. C is positive, D is positive. All right. E, F, and G are all negative. H, I are both positive, and J is 0. All right. So for the derivative, so for the derivative, A and B are positive, C is 0. All right. D and E are negative, F is 0. All right. G, H are positive, I is 0. And then J would be negative. Yeah. Now, when the function is concave up, okay, f double prime is positive. Where the function is concave down, f double prime is negative. So it is concave down from A, B, and C. At D, it says it's inflection point. So my inflection points D and H are where the double prime is 0. So I'm going to go ahead and put 0 for D and H. 0 and 0. So concave down up to there. All right, concave up in between, and then concave down. All right. So where f prime or f is increasing, f prime is positive, f is decreasing, f prime is negative. Where it's concave up, we have positive, which means increasing. All right, concave down, negative, decreasing. More questions. So that's where. Yeah. Number 18 on this, we're probably going to get to that on Monday, which is fine. As we're going to keep reviewing on Monday and then take the test on Tuesday. I will not be here Tuesday. You guys know Mr. Willett? You guys know Mr. Willett?
Mm-hmm.
He's subbing for Murray right now. He'll be here. He was the calc teacher before.
Yeah, there's no interview.
What?
Yeah.
Where's this page at then?
Oh, that's oh. Oh, okay. That's a different number.
Oh, okay. Just the numbering messed up. I think because what I did was I deleted the first page that had numbers on there, and so it messed up the numbering. Because we didn't really need the first page. The first page was just a big review of some of the previous units. So I just deleted it and then I didn't save it. All right. How time we got left? We got plenty of time to probably finish this page. But I do want to make sure we do focus a lot on number 18 because that's like a third of your test right there. Points. Yeah. The big idea is you need to understand the relationship between a function, its derivative, and its second derivative. Okay? So very, very important you know that. A lot of points on that question. All right. So we'll finish this page and then we'll do the rest on Monday. All right. So number what? What number are you guys at? 8. Okay. Sure. Number 8. All right. On which intervals is f increasing and explain? All right. When is the function increasing? When the derivative is positive. So we have the derivative, we have the zeros, so let's do a little chart here. We have -4 and 2. So we're going to pick values around there just to see what's happening. So if I plug in -5, that would give me a negative and a negative, so positive. If I plug in 0, that would give me a negative and a positive, so negative. If I plug in 3, I get a positive and a positive, so positive. So where's the function increasing? Everywhere up to -4, and then everywhere after 2. Yeah, we don't include. Yeah, since there's zeros, we don't include. I'm not going to be picky on that. If you put brackets, I'm not going to mark it wrong. Okay.
Next one is sure just to be because that probably x is positive.
At what x values does f have a local max? All right. Now, local max is where the function is increasing and then changes from increasing to decreasing, or the derivative changes from what? Positive, negative. So at x equals -4, f prime of x changes from positive to negative. It will be a lot of points on the explanation. Explanation. You tell I teach English sometimes just in my spare time. So on the explanation, there will be quite a bit of points on you knowing why something is this way. Okay, so you do need to know what it means for the f, the derivative change from positive negative, negative positive, what it means for the function to be concave up or concave down, for f, the second derivative to be positive and negative. So where the second derivative is positive, it's concave up. Where the second derivative is negative, it's concave down. Okay. Where you have the second derivative changing from negative positive or positive negative, you have an inflection point. Okay. So suppose the function contains the point 2, 0. Find the equation of the line tangent to the graph at x equals 2.
Yeah.
No, see, it says local max. Oh, it says local min too. I did not read the second part. So local max, okay, then local min at x equals 2 at prime of x changes from negative to positive. Yeah, I also teach handwriting classes. Obviously. Yeah, for teachers. All right, suppose the function f contains the point 2, 0. All right. Now, since the function is 0 at 2, what is the horizontal tangent line? So find the equation of the line tangent to the graph at x equals 2. X or y equals 0, right? So y is equal to, again, your slope, which is 0 times x minus 2 plus 0. So it's just y equals 0. Done. No, you don't. You can just say y equals 0. It's kind of a weird question. That's fine. I don't think that question's on your test. I can check because I have it open. No, it's not. I don't think I have any questions asking you to find the tangent line. This might be the first question. Test doesn't ask that. Yep, nope, none of that. All right, using your line in part C to approximate the value of 1.9 is an overestimate or underestimate the actual value of 1.9. Explain. I think this is just a review of the previous section, right? The linear approximations. We did that, so that's not your test. You can cross that out. It's fine. Yeah. All right, so find x values where h attains a relative minimum. I don't know if that's correct. All right. Relative maximum and inflection points of any. Justify your answer. So h, first we have to find h prime of x, which is 12x. First, let's put this in order. That's going to bother me. H of x equals negative x cubed plus 6x squared minus 1. So h prime of x would be negative 3x squared plus 12x. Here you can factor out a negative 3x to get x minus 4. So we have critical values at x equals 0 and x equals 4. Let's take the derivative of that. H double prime of x is negative 6x plus 12. Factor out a negative 6, we get x minus 2. So inflection point at x equals 2. All right. And you do need to justify your answer. Now, the justification, all right, will be that little number line that we use where we have 0 and 4, and then down here, the number line with just 2.
So if we have an underline, we don't have to like write anything.
No, you don't have to write explanation in words. You can just use your number line. So for our number line here, we pick values around -1, 1, and 5. So at -1, we plug it into the derivative function. So that would give me a positive and a negative, so negative. At 1, that would give me a negative and a negative, which is positive. And at 5, that would give me a negative and a positive, which is negative. So the function goes from negative to positive. So that's decreasing to increasing. So this would be a local min at x equals 0. And then it goes from increasing to decreasing. So local max at x equals 4. All right. And then here, as long as you can state that your second derivative changes signs, then you know you have an inflection point. It doesn't matter what signs it change. If the signs don't change, then you don't have an inflection point. Okay? So if you plug in, let's say 0 and 3 into the original function, 0 would give me a what? Positive, and 3 would give me a negative. So yeah, signs change. So inflection point at 2.
Just show me that number line, we don't even like.
Nope, you don't need to. Yeah.
You know if that works for me?
You would probably have to write it out for the AP test. Yeah. I would definitely go above and beyond my normal. Okay. Write out, like, show, like this, looking at this, will explain what happened in the diagram. All right. Last one for today. Find all local max and minimum points on the function whose derivative for all x is given by this function. So we have the derivative. So we have the derivative. So my critical values are 0, 3, and -1. Now you do have to test this because the signs don't change. Then it's not a max or min. Okay. So we have -1, we have 0, and we have 3. So we're going to plug in -2, plug in -1/2, plug in 1, and plug in 4. So if I plug in, now again, I don't care what the values are, I just want to know what the signs are going to be. So I plug in -2. Now the fun thing is, since these are always going to be positive, no matter what I plug in, because I'm squaring it, raising it to the fourth, when I plug in a negative, it's going to be negative. Where I plug in a positive, it's going to be positive. So the signs only change once, and that's where? At 0. Now, since it's going from decreasing to increasing, local min at x equals 0, f prime of fx changes from negative to positive. And again, that's all you would need to put, by the way, on the AP test. So local max this way, y, f prime of x changes from negative to positive. Nothing else changes, so there are no actual mins or max other than 0. All right, we will finish the rest of this on Monday. All right.